class boundaries, how to calculate for what the class width, and how to know what if we say the class limit, what is the class limit. If we say class interval, what is the class interval. So please take time and relax. I'm going to take through all this. Thank you. So please, I'm going to list the terms on the board, then we'll take you from there. Okay, so we have class mark, we have class boundaries, we have class width, we have class limits, and we have class interval. So please, I'm going to take my time and explain all this to you. The first one is the class mark, we have the class boundaries, we have class width, we have class limits, and we have the class interval. So I'm going to take time and explain them to you. So please, let's start with the class interval. When we say class interval, assuming I have this 1 to 5, 6 to 10, 11 to 15, 16 to 20. Assuming if I have this is called what? My class intervals. So the range from 1 to 5 is my first class interval. 6 to 10 is my second class interval. 11 to 15 is my third class interval. 16 to 20 is my fourth class interval. So in all, this distribution contains 4 class intervals. So please, I hope now, if you are asked of class interval, you'll be able to identify what a class interval is. So this is called the class interval. So we have the first class interval, the second class interval, third class, and the fourth class interval. So we are done with the class interval. Let's go to the class limits. So under statistics, basically we have two types of the class limit. We have the lower class limit and we have the upper class limit. So I'm going to take time and explain what is the lower class limit and what is the upper class limit. So I'm using this first class interval. With this first class interval, that's 1 to 5. The 1 is my lower class limit. 1 is my lower class limit and the 5 is my upper class limit. So with the class limit, with this class limit, we have two. We have the lower class limit and we have the upper class limit. So always the number on your leftmost side is your lower class limit and the number on your rightmost side is is your upper class limit. So with this first class interval, the 1 is my lower class limit and the 5 is my upper class limit. Here too, the 6 is my lower class limit and the 10 is my upper class limit. So please, that's the explanation of the for the class limits. Let's go to the class mark. When you are asked to find the class mark here is the same as the midpoint. So whenever you are asked to find the class mark for a given class interval, we have a formula that we use for to solve the class mark or the midpoint. So I'm saying that the class mark here is the same as the midpoint. So when you are asked to find the class mark of a given class distribution or a given class interval, we add the lower class limit to the upper class limit and we divide by 2 to find the midpoint or the class mark. So if I want to find the class mark or the midpoint, the formula is is your lower class limit. The LCL is lower class limit plus the UCL. That's your upper class limit all over 2. This is how to find the midpoint or the class mark. So it's your lower class limit plus your upper class limit over 2. So assuming if I want to find the class mark or the midpoint, if I want to find the midpoint, of this first class interval, I add my lower class limit to my upper class limit, then I divide by 2. So this is how I will do it. So it will be 1 plus 5 over 2. So it will be 6 over 2, making 3. So the midpoint of of the first class interval is 3. Why? I added my lower class limit to my upper class limit and I divided it by what? By 2. So please, basically, that's how we use, or the approach we use in finding what? Our class mark or our midpoint. We add the lower class limit to the upper class limit and we divide by 2. Please, I hope you are okay. Good. Please, let's go to what? The class boundaries. If we are asked to find the class boundaries, we use what? A determine what? Formula or an approach. To find what? The class boundary for a given class interval, we subtract 0.5 from the lower class limit and we add 0.5 to the upper class limit. So please let me draw a table here. If I'm asked to find the class boundaries of a particular given class, so let's say I'm having this same class 1 to 5, 6 to 10, 11 to 15. If I'm asked to find what? The class boundaries. If I'm asked to find the class boundary of this first class interval, that's what? From 1 to 5, 6 to 10. So if I'm asked to find the class boundary of this first class interval, that's what? From 1 to 5. What I will do is that I'll subtract 0.5 from the lower class limit, then I'll add 0.5 to the upper class limit. So it will what? 0.5 is to what? 5.5. So I subtracted 0.5 from the lower class limit and I have what? Added 0.5 to the upper class limit to get what? My class boundaries. So this is how we get our class boundaries. So please, I want you to what? Continue this one for me. So the second one, I will do the second one with you, then the subsequent one what? You will do it. So to find the class boundaries for the second class interval, I will have to what? Subtract 0.5 from the 6 and add 0.5 to the 10. So here to what? 5.5 to 10.5. Please, I hope you are following. So if I have a class like, let's say 11 to 15, I want you to do it and see whether you are correct. So guess the answer. I want you to get the answer. It will what? I hope it will what? 10.5 to what? 15.5. Why or how? I hope we can justify ourselves. Yes, we can. Why? Because we what? We subtracted 0.5 from the lower class limit. That's what? That's 11. Making what? 10.5. And what? We've added 0.5 to the upper class limit, making what? 15.5. So please, basically, this is how we find our class boundaries. Please, I hope you are following. Very good. Okay, so please, I hope now, if you are asked to identify the class interval, we can. And if you are asked to identify the lower class limit, we can. Also, if you are asked also to identify the upper class limit, if you are asked to solve for the midpoint or the class mark, we can solve them. Don't forget, I'm saying that the class mark is the same as the midpoint, so please don't forget. And also, if we are asked to find our class boundaries, I hope we can solve them. These are all what? Simple and general terms that we have to be able to solve them. So next on the list is how to find the class weight. So the class what? Weight. So if we are asked to find the class weight, here we can use two different approaches to solve the class weight. The first one I'm going to show is what? Is to take the average of the number that has been given to you, then you divide by the number of classes. So the class weight, the first approach is what? Is to take the average. So that's what? Your maximum number minus your minimum number over what? The number of what? Classes. The number of class. The number of class here is that when you are giving an entry, you see, you group them in what? When you are consulting what? A frequency distribution table, you group them what? Into table. So let's say, assuming on your table, you group the numbers in what? In 7. Let's say 1 up to 7. It means your number of classes what? Is 7. And the maximum number is what? Is the bigger number in the what? In the entry they've given to you. The minimum number is what? Is the smallest number they've given to you. So if you are asked to find out what? The class weight is what? You take the difference between what? Your maximum number and your minimum number, then you divide what? By what? The number of class. This is the first approach we use to solve what? The class weight. The second approach is that assuming we've given what? This class what interval 1 to 5, 6 to 10, 11 to 15. When we are asked to find the class mark of this what class intervals, we subtract the first lower class limit from the second lower class limit, or we subtract the first upper class limit from the second what upper class limit to get our what our class what weight. Please, I hope you're okay. So when you are asked to solve what the class weight, we use two formulas. The first one is what take the average of the number that I'm giving to you and divide by what the number of classes. So you take the difference between your maximum number and your minimum number and divide by what the number of class. Or you can take what the difference between what the first lower class limit and the second lower class limit, or the first upper class limit and the what second upper class limit. So let's look at this example. So if I'm asked, and this way I'm showing, this is the simplest way to solve for the class weight. So if I'm asked to find the class weight of this distribution, if I'm asked to find the class weight of this distribution, it's very, very easy. So find the class weight of this distribution, that's what class weight. I subtract the first what lower class limit from the second lower class limit. So it is what 6 minus 1, making what 5. So this 5 is what is my class weight. The same thing, if you use what the upper class limit to find the class weight, you have to get the same answer. So let's do what the upper class limit what to solve it and see. So if I want to find my class limit, if I want to find my class weight using what my upper class limit, I will take the difference between what the lower class what the first what upper class limit and the second upper class limit. So it is what 10 minus 5, and the answer is what is 5. So you see, using what the lower class limit and the upper class limit gives what the same answer. Please, I hope you are following. So this is how we find the class weight. You take the difference between what the first lower class limit and the what second lower class limit, or the first upper class limit and the second what upper class limit, and in all you should get the same answer for them. Please, I hope you are following. Thank you. Okay, so please, basically this is how we find our class weight. I'll show you two what approaches in finding the class weight. First one, you can what take the difference between your maximum number and your minimum number and divide by the number of classes. Or just simple, you subtract your first lower class limit from your second lower class limit to get your class weight. Please, I hope you are okay. Good. Then we will also be asked to find what the relative frequency of what of a distribution. So what relative frequency? When we are asked to find the relative frequency of a distribution, is very, very, very simple. So I'm going to show you how to find it. So assuming we have this our class intervals like 1 to 5, 6 to 10, 11 to 15, 16 to 20. If we are asked, then this is the class interval. This is the class interval. We have our frequency here. So this is the frequency. So for the frequency, the frequency of the first class interval is, let's say, 2. The second one is, let's say, 3. The fourth one is, let's say, 5. And the fifth one is, let's say, 8. So if we are asked to find the relative frequency of this distribution, that's what the relative frequency. If we are asked to find the relative frequency of distribution, first of all, we have to sum all these frequencies together to get our total frequency. So we add these numbers. So 8 plus 2 give us 10, plus 5 give us 15, plus 3 give us 18. So it means our sigma f is equal to what? 18. Do you get it? So 2 plus 8 give us 10, plus 5, 15, plus 3, 18. So the summation of all the frequency gave us what? 18. So if we are asked to find the relative frequency of the first class interval, we divide the frequency of that class by the total frequency. What I'm trying to communicate here is that the frequency of this first class interval is 2. So we divide this 2 by the total frequency, that's 18. So it is 2 over 18. Please, I hope you are following. If we are asked to find the relative frequency of this second class interval, we take the frequency of that class and we divide by the total frequency. So that's also 3 over 18. So in all this, we follow the same order and we have to calculate for all of them. So that's how to find the relative frequency of a particular distribution or a particular class interval. And don't forget that, remember, whenever you are asked to calculate for the relative frequency of a particular given distribution, always the summation of all your relative frequencies will give you 1. So if at the end of the day I calculate for all of this and I add all my answers together, I have to get 1. If I don't get 1, it means I'm wrong. So the summation of all the relative frequency should give you 1. Please, we shouldn't forget. If you sum all your relative frequency, you have to get 1. If you don't get 1, it means you are wrong. Thank you for understanding me. Okay, now I hope you know how to calculate for our relative frequency. The next one is to calculate for our cumulative frequency. So cumulative When we are asked to calculate for the cumulative frequency, it's very simple and easy. With this one, we just need is It's just addition. So we will be adding our frequencies from top to down. So follow me and let's see how we do it. Okay. So if we are asked to calculate for our cumulative frequency, it's very, very simple. So I'm saying that we add the frequencies. So the cumulative frequency of the first class interval will be 2. Because there is no figure here for us to add. So always the first class interval, the frequency remains the same. It remains untouched and unchanged. But if you are asked to find the cumulative frequency of the second class interval, we add the frequency of the first class to that of the second class. So it will 2 plus 3, making 5. I hope you are following. If we are asked to find the cumulative frequency of the third class interval, that's we add that of the first to the second and to the third. So it will 2 plus 3 plus 5. Making 10. Please, I hope you are following. So that's cumulative addition. We are adding the figures. We are adding them. Cumulative. So always the first class interval remains unchanged. But with the second one, when we want to find the cumulative frequency of the second class interval, we add that of the first to the second to get the initial cumulative frequency. So guess what the cumulative frequency, the answer we get for this. So please, I want you to try and see the answer we get for this fourth class interval. I hope you can justify your answer too. Yeah, because it was very simple. We add this 10 to this 8 because this 10 sums this and that. We can choose to add from here, and here, or we can choose here because we know this 10 relate to that and that. Do you get me? So if you are asked to find the cumulative frequency of this last or the fourth class interval, it will 10 plus 8, making 18. So you see, this my last class. And don't forget that always the final cumulative frequency that you get is telling or is relates to that of your total frequency. So you see, my total frequency here is 18. And that of my final cumulative frequency is also 18. So you see, this and that they are telling you. Please, I hope you get me. So basically, this is how we find for our cumulative frequency. I hope you are good. Okay, now let's go to what? Measurement of what? Central tendencies. So with the measurement of central tendencies, we have some general terms that we look at. So under the measurement of central tendencies, we look at the mean, the median, the mode, deviation, standard deviation, variance, and the range. So look at what? The mean, the median, the mode, the range, deviation, variance, and what? And the standard deviation. So this what we are going to see or treat. So let's take the first one. So these are all what? Measurement of what? Central tendencies. So our first list or the first item what on the list is what? Is the mean. If you are asked to find the mean, it's very, very simple. So to find the mean of a particular given what? Set of numbers, we sum what? All the numbers, then we divide by what? The number of what? Occurrence. So it's the summation of all entries divided by the number of what? Occurrence. So assuming I'm asked to find the mean of these numbers, assuming I'm asked to find the mean of these numbers, I have to what? Sum all these numbers, then I divide by what? The number of what? Occurrences. So you see, I'll add the 2 and find the mean of these numbers. So it will be 2 plus 3 plus 5 plus 1 plus 2 plus 2 divided by what? The number of occurrences. So here we will count all the numbers. So it's what? 1, 2, 3, 4, 5. So here the number of occurrences will be what? Will be 5. So we sum all this together. So 2 plus 3 will give us what? 5. Plus 5 will give us what? 10. Plus 1, 11. Plus 2 is what? 13. So you will get what? 13 over what? 5. So 13 over 5, we can what? We can break it down. 5 goes to each cell what? 1. 5 goes into 13 how many times? 2. So 5 over 13 we get what? 2.6. So this becomes what? Our final answer. I guess we'll be demanding to know why I get the 2.6. So 5 goes into 13 how many times? 2. Remaining what? 3. So we add 0 to the 3 making what? 30. 5 goes into 13 how many times? 6 times. So it's what? 2.6. This is how we are okay. So basically this is how we find our mean. We sum what? All the entries, then we divide by what? The number of what? Occurrences. Let's know how to find the median. So with these same numbers, if we are asked to find the median of these same numbers, remember, whenever you are asked to find the median of a particular distribution or numbers, we what? We have to what? Rearrange the numbers in ascending order. The median is simply what? The middle number. A median, at times when the number given to you is an odd number, you will get only one median. But when the number is given to you, they are what? An even number, you get what? 2 medians. So when you get 2 middle numbers, we add these 2 numbers and we divide by 2. So look on the board and let's try this example. So if you are asked to find the median of these numbers, median simply means what? The middle number. So per the arrangement of this, when this one is given to us in the exams, you see, by looking at this, we can clearly say that this 5 is what? Is the median, because it's what? It's the middle number. We have 2 digits here, 2 digits here, so the remaining one is what? Is our median. And we are wrong. Why? Because we did not arrange the numbers in ascending order. So remember, whenever you are asked to what? Find the median, you have to rearrange the numbers given to you again in ascending order. So look on the board. So from ascending order, I have what? My 1 here, I have my 2, I have my 2, I have my 3, and I have what? My 5. So with this, after arrangement, I can clearly say that 2 becomes what? My median. So here, the final median and the correct median is what? Is 2, not 5. So don't forget to rearrange the numbers again in ascending order. Please, I hope you are good. Okay. you see, this one is what? It's an odd number. That's why we have what? Only 1 median. So assuming we have, let's say, 7 added to this. So in arranging, we have what? 2, 3, 5, and what? And 7. So with this, they are what? 1, 2, 3, 4, 5, 6. They are 6, and 6 is what? It's an even number. So because it says, it means we get what? 2 middle numbers. So here, this is what? This is the first 2. This is the last 2. So these 2 numbers becomes what? Our median. And we don't have 2 answers for the median. We only know what? Or we only want one answer. So it means when you have 2 medians, after we what? Arranging the numbers and finding that you have 2 medians, we add them together and we divide by 2. So look on the board. So we get what? 2 plus 3 over 2. Making what? 5 over 2. That's what? 2.5. So the 2.5 becomes our median. Please, I hope you get me. Okay, cool. So we are done with the mean. We are done with the median. Let's come to the mode. Mode is simply the number that appears most, or the number with the what that appears most. Let me use that way. So when you are asked to find the mode of a given what numbers, the number that occurs most is what is your mode. So per this example, we can say that 2 what appears what twice, and because 2 appears twice, 2 becomes what our mode because it appears most. Sometimes you get 2 numbers that what will appear twice, and these 2 numbers become your mode. Example, let's say I added 7 again. So if I added 7 again, it means we have 2 of the 2's here and we have 2 of the what of the 7's here. So here it means we have what bimodal, whereby the mode what becomes 2. So here with this example, our mode becomes what 2 and 7. Please, I hope you are okay. Let's go to the range. If you are asked to find a range of a particular given distribution, it's just what the difference between the maximum number and the minimum number. So per this distribution or per these numbers I've written on the board, if I want to find the range, I subtract my minimum number from my maximum number. So it will what? The minimum number here is 7. So it will be 7 minus my what? This is my maximum number, that's what 7. My maximum number is what is 7. And my minimum number is what? Is 1. So 7 minus 1, give me 1 in what? 6. So this 6 is my range. Please, I hope you are following. So basically, this is how we find the range. Let's go to the deviation. When you are asked to solve for deviation of a particular given set, deviation is simply what? How much the mean deviates from each entry. So for how long or for how much do what the mean deviates from each entry. So assuming we are finding what the deviation. We are finding the deviation of, let's say, these entries 2, 2, 3, 1, 2, 2, 2, 2, 5, 10. Okay, 1, 2, 3, 4, 5. Okay, 5. So if we are asked to find the deviation of these numbers, first of all, we have to find the mean first. Without getting the mean, you can't solve for the deviation. So we solve for the mean. So we add all these entries. So it's what? 2 plus 2 plus 3 plus 1 plus 2 all over what? 5. So summing this all, we get what? 10. So 10 over 5 is what? Is 2. 10 over 5 is what? Is 2. So this 2 becomes what? Our mean. Now, to find the deviation, we subtract these 2, that's our mean, from each entry. So look at how I'm going to do it. So let's say we have the entries here. So we have 2, 2, let's say we have 1, 2, then another 2, then 3. So these are what? These are my numbers. This is the numbers. So my mean was what? Was 2. And with deviation, the formula is what? Is x minus what? X bar. So the x is the entry minus x bar. The x bar is what? Is the mean. So we subtract the mean from what? From each entry. Please, I hope you get me. We subtract the mean from each entry. So it will be what? The x is what? Is 1. So it will be 1 minus 2. Because our mean is 2. So this 1 minus 2, this minus 2, this minus 2, and this minus 2. So in all, you see, we will get 1 minus 2 is what? is negative what? 1. This we get 0. This we get 0. This we get 0. This we get what? 1. We get 1. So in all, when we sum all this, you see negative 1 plus 0 is negative 1. Plus 0 is negative 1. Plus 0 is negative 1. Negative 1 plus 1 is 0. So you see our final answer here is what? Is 0. So it means whenever you are asked to find the deviation of a particular what? Data, always your final answer, when you sum all your deviation, you have to get what? 0. If you did not get 0, it means your approach is wrong. Always the sum of all deviations should give us what? 0. Please, I hope you are okay. Good. So let's come to what? The variance. When we are asked to find the variance, it's very, very simple. Once we get what? Our deviations. So these are our deviations. When you are asked what? Find the variance. We are to find the variance, we use this formula. So to find the variance is what? Summation of what? S minus S bar all squared over what? Capital N. So this is how to find what? Variance. And with the variance we have what? Population variance and we have what? Sample variance. So whenever you see capital N, it means you are solving for what? Population variance. So when you are solving for your variance, it means you have to what? Get your deviation first. So with this deviation that I have here, you see it's what? S minus S bar, and this S minus S bar is what? Is the deviation. So the summation of the deviation squared over N. So this answer that I've gotten here are what? I'll square all of them. I'll square all of them. So I'll square them. I'll square them. So if I square all of them, then what? The final answer that I'll get, you see, if you square this, if you point on the calculator, you get 1. So it's what? 1, here will be 0, here will be 0, here will be 0, and here will be what? 1. So in all, I'll get what? 2 for what? For the summation of what? Of the deviation squared. So when I got 2, it means that all the top here, the answer is what? The answer is 2. Because after getting your deviation and squaring all of them, when you sum all, I got 2. So these 2 what? Represent the entire top there. So it will be what? 2. So variance is what? This is a symbol for variance. Q, like it's like Q then square. Do you get me? So I sum all this and I got 2 after squaring them. So these 2 represent the entire top here. So it will be what? 2 over n. The n is what? The number of occurrence. So here you see I have 1, 2, 3, 4, 5. So it means my n will be what? Will be 5. This I hope you are following. My n will be 5. So here my variation, sorry, my variance will be what? 0.4. So this 0.4 becomes my variance. So when you get your variance, calculating for the standard deviation becomes easier. So when calculating for the standard deviation, you just what? Square root your answer for the variance to get your standard deviation. So look here, if you are asked for what? To find the standard deviation, I'm using SD. SD means what? Standard deviation. You what? We root the what? The variance. So the variance here is what? Is 0.4. So if I root the 0.4, the answer I got becomes what? My standard deviation. So it's what? Root 0.4. So when you point this on your calculator, the final answer you got or you get becomes what? Your standard deviation. Please, I hope it's cool. So basically, this is how we solve for what? The central what? Tendencies. The mean, median, mode, range, variance, deviation, and what? Standard deviation. Thank you.